Hey, hello. How are you? Welcome to the lesson graphs of graphs. We are looking specifically on the straight line. We are looking specifically the straight line, which is characterized by a formula or rather an equation y is equals to mx plus c. Let's look into our agenda. We are first going to look into a vocabulary where we speak about the x and the y axis. We are speaking about the coordinates of a point. What do we mean? We're going to speak about equation of a straight line. We are going to talk about what is gradient and what is actually the y-intercept. We also going to look at finding the gradient of a line through 2 points or more. We are also going to find the gradient and the y-intercept of a straight line from its equation. We are going to just look at the equation and be able to establish what is the gradient and what is the y-intercept of that particular straight line. We are also going to compare two straight line graphs using their equations. Let us go back into characterizing what we call the x and the y-intercept. So the x-intercept is the horizontal one, and the y-intercept is actually the vertical one. We talk about the x and y-intercept as being the axis of that particular graph. We call it the x-axis and the y-axis on the Cartesian plane. There is a x-axis and the y-axis where? On the Cartesian plane. This is not a graph, it's the Cartesian plane. We are having that point A, which is x map y. It has the coordinate, the x coordinate is xa, the y coordinate is ya. So the coordinates are always in the form of x map y of a point. A point has coordinates on x and y. And for this particular point specifically, it's 6 map 6. A is the point 6 map 6. We can from there draw, because we already have the point, the origin, which is 0 map 0. We can definitely draw a line from the origin to the point 6 map 6. There we have our straight line, and we can just put any other point on that particular straight line. Here I'm putting 2 map 2, and we can use that particular point because we need 2 points to create a line. We can definitely use that particular point to establish the relationship between x and y, and the line will be in the form of y is equal to mx plus c. Y is equals to mx plus c, and that is the equation of that particular straight line. We call it the slope-intercept form. The line y is equals to mx plus c is called the slope-intercept form, which I also call it the standard form. The m is the value of m is the gradient, and the value of c is of course known as the y-intercept. It's also known as the constant, but in terms of graphs is the y-intercept, in terms of the straight line graph specifically. Therefore, we can go further and say, for example, when we have y is equal to 5x plus c, can you see? This is actually in the form of y is equal to mx plus c. So when we have y is equal to 5x plus 4, you can see that the 5 stands for the m because it's the coefficient of x, and the 4 is actually the constant. So we can therefore now declare to say, yes, this is a straight line graph. Why? Because it's in the form of y is equal to mx plus c. That is why we have y is equal to 5x plus 4, where the 4 is the c and the m is the 5. So remember, the gradient is m, so the gradient is 5, and the y-intercept is tell me, it is 4. Awesome. Let us look at the denotions of this particular equation in other countries. Remember, in South Africa, in UK, in Australia, in Egypt, Germany, and Malawi, most of the countries in Africa, we use y is equal to mx plus c. But if you go to your Vietnam, you'll find that they use y is equal to ax plus b. Countries such as Greece, they would use things such as, or rather Italy, y is equals to mx plus q, blah, blah, blah. So there are many denotions or representations of this particular formula, but it's the same thing. It's just in the form of y is equals to mx plus c. And the gradient, what is the gradient specifically? It is the measure of steepness. It is the measure of how steep, how sharply angled a line is. A gradient is also known as the slope. A gradient is also known as a slope. So if the line is horizontal, it's just, when the line is horizontal, it means it's parallel to the x-axis. When the line is horizontal, the gradient is 0. And when the line is parallel to the y-axis, meaning when the line is super vertical, meaning it's perpendicular to the ground. When the line is vertical, the gradient is undefined. The gradient is undefined. And when the line is going uphill positive, meaning when it's slanting towards the right, then the gradient is positive. And when the line is slanting towards the left, meaning it's going downhill, the gradient is negative. Since the gradient is the measure of how steep a line is, I wish there is an escalator. What a workout when the slope is positive. Or what a workout when the slope is positive. Let's look into this. Remember, gradient is the measure of how steep a line is. So, wow, this is easy when the slope is. This is easy when the slope is negative downhill, baby. Negative downhill, baby. So that is when the gradient is negative. Gradient is the measure of how steep a line is. Life is fair. Listen to that. Beautiful. I love this. Life is fair on a level ground when the slope is 0. When the slope is 0. And wow, this is what they call a free fall. I feel weightless, at least for the moment. And it happens when the slope is what? When the slope is undefined. It happens when the slope is undefined. So using the equation of the straight line, use of the gradient in the equation of the straight line, y is equal to mx plus c. The vertical distance is called the rise or fall, and the horizontal distance is called the run. And of course, the gradient is always the rise or the fall over the run. The rise over run, meaning the gradient is the vertical change over the horizontal change. And this is how it's denoted. When there is a change in y, which is a rise or a fall, over the change in x, which is known as the run. You look into this example, the change in y is 3 units, and the change in x is 5 units. So that is, the gradient becomes what? The gradient becomes 3 over 5. We can also use the coordinates of any 2 points of the line. Let's see. The change in y, which is denoted by delta y, and the change in x, in x there, that's the change in x, which is denoted by delta x. Use of a gradient of a line, another way to visualize it is this way. Gradient or slope is a change in y over change in x, which is y2 minus y1 over x2 minus x1. These x2 and x1 and y2 and y1, they are just dummy coordinates. It's any points on the graph that you may be using, or on the straight line that you may be using at a certain point in time. So I just want to tell you that wherever there's an x2, there is going to be a y2, and whatever point you choose to make an x1, it is going to have a y1. So you can't have an x2 being coupled with a y1 and the other way around. That cannot happen. Be careful of that. Let us calculate a slope for these lines with the coordinates. We're having coordinates 2, map 3, the x coordinate is 2 and the y coordinate is 3, and the other one we are having 6 at A 6 map 4, and at C we are having 4 map 5. And there we go. Oh ho ho, I don't know what's happening to my slides there, but it's fine. It's failing while I'm on the video. It's okay. It's okay. Let us, with that understanding, you do understand how we work around the founding of the gradient. Let us now find the gradients of the next 5 slides. Let us look into this one. Here is a graph with 2 points. You see one point is 0 map 0, the origin, and the other point is 1 map 1. So what is going to be the gradient? There we go. The y2 minus y1 and the x2 minus x1, or the other way around. And when you get the gradient becomes what? 1. And let's see here. Let's get 2 points. 1 map 1 and the other point is 3 map 4. Let us put this into the gradient equation. The 4 minus 1 over the 3 minus 1. 4 minus 1, the y coordinate subtract the other y coordinate, the x coordinate subtract the other x coordinate, and it becomes the slope of 3 over 2. And you'll see that the slope is positive. 3 over 2, it's positive. And as it's positive, it's slanting towards what? Towards the right. It's uphill positive. Check here, the slope is negative, ne? So our gradient must be negative. Can you see? Our graph is slanting towards the left. Let's get our points. Yeah, you'll see the point there is 3, it's minus 1 map 3. And then the other one is 0 map 0. 0 map 0. So you can see the change on the x is minus 1 and the change on the y is 3. So that is minus 1 map 3 and 0 map 0. The gradient thereof becomes 3 minus 0, or minus 1 minus 0 is equals to minus 3. And it is negative. Also here the gradient is going to be negative because it's slanting towards the what? The left. And you can see there's 3 units. There's a negative 4 units because it's going to the left. And let's see now. The point is minus 6 map 5 and minus 2 map 2. And when we calculate the gradient, it should give us 5 minus 2, the y minus y. It gives us a 3. The minus 6 minus 2 gives us that 4. And all together we have just a minus, minus 3 over 4. Let us look at the next one. When we have those particular points, we've got the point 0 map 1 and we've got 0 map 3. No, we've got 0 map 1 and then we've got 3 map 1. Yes. And then the gradient is, of course, 0. I took this in a certain question paper. Certain textbook actually. A crane is lifting a boat suspended by wire ropes and blah blah blah. The point C is vertically below. Can you see? Below A, it's vertically below A, and BC is how many meters is BC? 5 meters. Okay. And then the gradient of AB is 0 map 8 is 0.8. 0.8. How high is A above C? So we can be able to calculate such questions, especially we find them in physics. Whereby you've got one side being 5 meters, the gradient being 0.8, and then of course you can use uh, methods. It can be methods of whether Pythagoras, it can be methods of understanding the issue of gradient. Since now we know what is the gradient, we can be able to get the how high is A above C. We can be able to get that. In triangle ABC, we have the gradient being 0.8, but the gradient is 0.8, but the gradient is actually AC over BC. So we can actually solve for AC by making it the subject of the formula. Remember, there is a lesson about how do you turn around something being the subject of the formula. That is why we have 4 meters there. And then you can, of course, see how we also calculated if the gradient 80 is minus that in the other triangle, what is the length of the boat, the total length of the boat. All we need to do is to find DC, which we have found as 3.2 meters, and then add BC and DC. BC and CD or DC, all together they give you the length of that particular boat. This is a little bit harder. One of the world's tallest roller coasters is in Blackpool, England. The maximum drop is 65 meters. Can you see the drop? 65 meters, meaning that is actually the vertical distance from the top in over a horizontal distance of 65 meters in 2 sections. The first section has a gradient of 3, and the second section has a gradient of a half. How high is the point A above the ground? This is beautiful. But you need to be able to establish those particular right-angled triangles. It's 2 of them, and you will also find a rectangle there. You need to realize you need to insert some variables. Let's introduce distance A and B, which we did in order to form that particular triangle. And then from there, we can definitely move and calculate all that we have to calculate. And I challenge you to do that. Now, if the gradient is, then the line will be steep. If the gradient is what? Large. If the gradient is large, then the line will be steep. If the gradient is large, then the line will be steep. A gradient will slope downward from left to right. A what gradient? A negative gradient. A negative gradient. A gradient will slope upward from left to right. A what? Obvious. A positive gradient. A positive gradient. The gradient of a line is the gradient of, check the line. How does the line look? According to me, the line is horizontal. The line, according to me, is horizontal. A gradient of a horizontal line is, according to me, is 0. You remember? It is 0. That's A. The gradient of a, can you see the line is vertical? Of a vertical line is undefined. It's undefined. Lines that are lines always of equal distance apart, and the gradient of both lines is yes, lines that are parallel. Parallel lines have the same equal distance apart, and the gradient is the same. The slope-intercept form, the m value is the what? Is the gradient, and the c value is the, you remember? Y-intercept. And then slope-intercept form, y is equal to 5x plus 4. you will remember m is the gradient, and y is equal to 5x plus 4. Let me give you that example. The gradient is 5, and remember the y-intercept is 4. If you look into this particular, if the gradient is 1, let's say, if the gradient is 1, minus 1, for example, and the y-intercept is minus 1, how do we write the equation? If the gradient is minus 1 and the y-intercept is minus 1, how do we write the equation? We write the equation as y is equal to minus x minus 1. And we can actually show that it passes through those points. When the gradient is half and the y-intercept is 2, how do we write the equation? That is our equation. Y is equal to half x, 1 over 2x plus 2. When the gradient is 3 and the y-intercept, tell me, what's going to be the equation? Yebo. Y is equal to 3x minus 6. So it is important that we end this by just saying that is how we work around the issues of the straight line. The straight line is generally the form of y is equal to mx plus c. The use of the gradient in the equation of the line y is equal to mx plus c, where m is the gradient and c is the y-intercept. The lines y is equal to mx plus b as a gradient, or plus c, when it has a gradient of minus 3, how do we find the equation of the line if we know a point is on the line? All we know is that, okay, fine, y is equal to minus 3x plus c. So you already know the gradient. And then when the point is on the line, remember the point 2 map 1 is the x coordinate and the y coordinate. So you need to solve for c. So you need to actually substitute the x coordinate and the y coordinate there. How do we do that? There I substitute the x coordinate as 2 and the y coordinate as 1. Then I will solve for c. When I solve for c, according to me, c will be equal to 7. And when c is equal to 7, the equation thereof will be y is equal to minus 3x plus 7. And that is where we are. Thank you so much. We appreciate. Hi.